looking at the effects of climate change on fruits and vegetables in the mid-Atlantic, and can we do anything about it? We grow, probably over 100 different things that would fit in the fruit and vegetable category, and a lot of them are very susceptible to changes in the environment. So looking at, this happens to be from southern Delaware, there's a great site you can go and create these charts for whatever region that you are in the mid-Atlantic. But as you can see, our average temperatures have been increasing, particularly over the last 3 decades. We're seeing a steep rise in our average temperatures. We have a lot of variability in our maximums, but we have seen record maximum temperatures over the last 2 decades. This is the one that is really concerning from a fruit and vegetable standpoint, is that our nights are getting warmer consistently. You can look at that over the last couple decades, and we have had, again, record night temperatures. Looking at just the growing season months, we can see our maximum temperatures. Historically, we had in the 40s, we had a little warm bump, but since the mid-80s, we've seen a steady increase in our maximum temperatures during the growing season. Take a look at a year like 2012, which was the hottest on record in our region, and you can see we're over 100 degrees multiple days. This can cause havoc with a lot of our vegetable fruit crops. The other thing is that we're getting more extreme events. So in the red here is where you have our minimum temperatures are much above normal. What percent of the season of the year was that occurred? It's all in the red, folks. This is the Northeast, not just in our area. And you look like a year like 2012, 90% of the days were in an extreme event for minimum temperatures. Compared to the average. Bring it a little closer to home. This is mid-shore. Over the last 7 years, we have 5 of the last warmest July minimum. So the night temperatures have been warmest here, and here. And even you notice that we had 2 cool years, but one was at the average for the 100-year average, and one was still above average, even though they were cool years. I took another issue that we're having is false springs. We've had 2 false springs in the last 5 years. The talks that were given on Tuesday, this is likely to continue for at least a decade. So we're likely to see a couple more false springs, and this is really bad for fruit growers because you get bloom and then you get frost outs with crops like peaches. Rainfall is increasing. This isn't necessarily a bad thing. What the problem is oftentimes this rainfall is extreme events, so that you get more rainfalls over 2 inches where you have occurring within a couple-hour period. All right, so what I'm going to concentrate on is heat effects on fruit and vegetables, and what are some of the mitigation tools that we have out there. This is all review for all of you. Most of you are plant scientists. Of course, you get an overall heat causes reduction in overall yields through lower photosynthesis, increased respiration, and reproductive failures. We can also have a lot of quality issues, either size and shape calls or internal defects like tissue death or tissue damage. And then mortality, we can get premature senescence, so we don't have as long a harvest period for some of our crops, or we can get plant losses like when we're at transplanting. So these are some of the examples of some of the heat defects we get: white tissue in tomato, internal necrosis in potatoes, white areas on berries, yellow shoulders on tomatoes. Again, these are complicated in that they're not just heat, it's heat in combination with something else oftentimes. Brown bead, the bead death and irregularities in broccoli, stem necrosis in transplants. And then heat in combination with some other factors can increase the amount of sun scald and scorch. If plants wilt a little bit, then the canopy opens up and we get a lot more scorch. I was in a field where they missed one of their drip irrigation schedule for pepper. The whole field, 40% scorch on the field, just lost a huge amount of the crop. We had a lot of problems with watermelon scorch this year. I had people asking me, well, should I be using one of these particle films to control scorch? Get the same problem in tree fruits, berries. Even in sweet corn, certain varieties, we'll see leaf scorch, which doesn't affect the ear, but it can affect the overall productivity by reducing photosynthetic area. We get this physiological leaf curl in some of our vegetables. What this does is if they get it into a combination drought and heat stress, the leaves will curl. Now the canopy is open. We get these disorders with scorching that we saw earlier. Of course, from a reproductive standpoint, heat can affect our development of fruits and seeds, so poor pollination, abnormal fruit or seed development. And then in a lot of our crops, we get this issue with split sets. So we'll see when the temperature's conducive to setting fruit, they'll set fruit, and then there'll be a period where they don't, and then they'll be go back to when the temperatures are more in the range where they can set fruit. So here you can see one lima bean pod here, nothing in the middle, and then new lima bean pods developing there, and a bunch of flowers on the ground. Really hard to schedule processing crops with split sets. You know, what you go for the few on the bottom, or do you wait till these get over mature and you get the next one? And this can cause a lot of problems as far as yield too. And then high temperatures interact with the physiology of the plant. It's not the only factor oftentimes, but it can increase bolting or premature flower development. So I'm going to concentrate on what are those mitigation tools that are available to us and how might they be used. So things like mulch, radiation block, shade, metabolic regulators, evaporative cooling, root inoculants. Then just mention the adaptive heat mitigation as what you want from a long-term standpoint. These are more short-term tools. This is where you want to go from a long-term standpoint. So of course, if you're growing on plastic mulch, the tool that's been available to us for many years now is to change mulch colors to reflective mulches, so white on black, silver, or metallized mulches. Or you can go into moving back onto a more natural mulch. So again, you're reducing the root zone temperature, and that can affect plant development positively under heat stress. So we're getting some more crops growing on rolled covers. As far as changing mulch colors, this is from a colleague in Georgia we had up for a talk a couple years ago. For their fall crop where they're laying the plastic in late summer, you can see that the reflective mulch has really reduced down the temperature by degree and a half, which can be a big difference as far as having some of these defects related to hot root systems. Can backfire on you. Did a real simple experiment a couple of years looking at some mulch colors. Where the idea was we're likely to get our first heat events in Delaware around Memorial Day, so planted around Memorial Day on the aluminized black or white mulch. And actually these plants did not grow until it got warm. It was just too cold. So it doesn't work if it's not hot. So you know, how do you predict where you're going to need to change mulch colors? And that's something that we're going to have to try to figure out. Fruit defects. A lot of this is related to heat. So you can see fruit defects in tomatoes, yellow shoulders, and there'll be white internal tissue versus ones that aren't affected. This work from Jerry Bruce over at University of Maryland, looking at on white mulch, which is in the red, versus black mulch. And you can see in some varieties it made a big difference as far as marketable tomatoes. Some varieties were less affected. All right, so that's one tool is mulches, changing your mulches to things that either insulate or reflect. Some of those reflective mulches can reflect up to 50% of the light back up, and it actually has dual benefit in that you get some more light up into the canopy too. But if you ever worked on reflective mulch, it'll about blind you in the middle of the summer. Radiation blocks, reflective materials, and anti-transparents. I lumped these into one group. The one that's been used for a long time and have been available is particle films. These are either clay or lime-based. There are other materials that have been used. but these are the two most common. This isn't anything new. People have been putting lime on plants to reduce sunburn for centuries. But there's been a lot of work with these materials in probably the last 20 years as to some of the other possible benefits that they have. There are also some wax-based materials that block radiation or reduce the amount of damage to plant tissue. Anti-transpirants, the one that there's been quite a bit of work on more recently is low levels of acetic acid, which closes stomates. And they've used this to treat transplants prior to transplanting and reduce transplant shock. On the whole, we don't see a lot of use for anti-transpirants in the vegetable industry or fruit industry for mitigating heat. The reason is if you start closing stomates or clogging up stomates, you also reduce down gas exchange, and then you get reduced photosynthesis. Where a lot of this work regained a lot of momentum was with some of the work out of the Fruit Research Station in West Virginia, where they were using these particle films on apples. They showed improved photosynthesis, improved fruit quality, improved yields by doing this. And so it's gained some momentum from this most recent work. I've done a little bit of work with watermelons using particle films either at low rates or at higher rates. So we make them real white or just reduce down some of the heat loading. And with some variable results here, you can see numerically higher with this low rate sprayed on a weekly basis compared to the control, but it's not statistically different. However, when we look at some of other parameters like fruit weight, we can see that we're getting where we use these are particle film at different rates and different timings. We can say we're getting improved fruit weight, increased fruit weight by using those. We didn't really improve fruit number that much, but we can improve the fruit weight. However, on a cold year or a cooler year, this is our particle film. Did it do anything? Actually reduced yield. So again, how we use these, when we use these, we're going to have to figure that out. So there's going to be some critical temperatures, and we're going to have to do some forecasting. Is it going to continue to be hot or not to really see if these can be good tools. Shade. So shade's been used all across the tropical area of the world to grow vegetables under in hot conditions. Shade netting, there's black, green, white, and luminate are the four colors that we normally use. We're using 20 to 30% shade. You get above that, you're reducing down photosynthesis enough that you're actually cutting into yields. Although we use heavier shade for some nursery crops and crops that need heavy shading. So this is from Jerry Brust over at University of Maryland. Again, looking at fruit quality in tomato, where they used two different types of mulches, but also included shade. And you can see the shade made a big difference in marketable tomatoes. Did a little bit of work with trying to do some summer production of strawberries a number of years ago. And here is the silver aluminized shade versus white shade. And for certain varieties, this happens to be EV2, you can see that we got a big boost by using the shade. In others, we didn't see that. Happens to be Albion. We didn't see much of a difference between using shade or not using shade. So again, with some varieties, it did provide us with additional yield. Another category of mitigation tools are metabolic and developmental regulators. These fall into a couple groups. The first are ethylene inhibitors. This 1-MCP is used as a commercial product for transplant survival. So this land spring you can treat your transplants with, and it helps reduce ethylene synthesis, which causes abscission and senescence. So this is available for some use. It's not available for spraying on later in the season, at least currently. Strobilurin fungicides supposedly have an effect of blocking ethylene. It's a little controversial out there. I'm not going to go into this into detail, but we do know that it's being used in some crops to stay greener longer, and that's likely the method that why it's doing that. And experimentally, we use thiosulfate for the same thing. Too expensive to use on a regular basis. Then some of our growth regulators, hormones, cytokinins, and jasminates have shown to have some effects on reducing stress. And there's a good bit of literature on those. Then another avenue is, okay, if we're having problems setting fruit, can we set fruit artificially or with a hormone? And yeah, this has been done in the past. There's research that's using auxins and gibberellins or combinations. One that's used commercially overseas for setting watermelons is CPPU. So we can actually set a watermelon without ever having fertilization occur. All right, so we actually get a seedless watermelon even if it was seeded to begin with, or would have been normally seeded. So I've done a little bit of work with this, looking at cytokinins, jasminates, and strobilurins and combinations over the years. And in some cases, this was a hot year, as you know, 2012, where we combined several of the materials together, where we had a cytokinin, the particle film, and the strobilurin. We did get quite a decent yield bump. We didn't get it with the single products alone, but where we combined several of these strategies together, we did. Same thing here in 2013 under dry land where it wasn't irrigated, where we combined several of these together, we saw benefit. However, we get into a cool year. See any difference there? No. Why? It's a cool year. All right, no stress. Another tool that's been used commercially in other areas of the world, and we do this a little bit in crops like pole lima beans. We'll have folks put misters above their trellises, is evaporative cooling. Of course, in greenhouses, we've used evaporative cooling forever, fogs and misters, but this use of sprinklers, either continuous or pulse, we're using low rates of water where it never ever reaches the ground. It is in the canopy and it evaporates off, cools the plants, is something that we may need to start looking at in some crops. So this is an example from an Australian study where they were using this pulsed sprinkling, where on 20 minutes, off 20 minutes, on 20 minutes, off 20 minutes. And this is skin temperature. You can see the reduction in skin temperature by using this pulsed evaporative cooling. So this is being used commercially in some areas of the world, and as it gets warmer, just another tool in our toolkit to, if on our high value crops that we may want to revisit. There's a whole lot of literature on if we add something to the roots, it's going to make it more stress tolerant. And unfortunately, most of that has good scientific base to it. We certainly do know that mycorrhizal fungi, when used as an inoculant, increases roots, effective root area, and it can make the plants more stress tolerant. One that we've worked with at the University of Delaware is this Bacillus subtilis. We have a particular strain, this 1022, that's going to be commercialized, but we add it as a root inoculant. And this is 4-hook lima beans, which are very heat sensitive. Lima beans are a great test crop because they're very susceptible, at least the current varieties that we have, to heat. Anyway, with adding this bacteria, these are different rhizobians we added, but when we started adding these different bacteria, we started seeing, these are your controls, quite a yield bump just by adding this. And we're not sure what the mechanism is. There's some induced resistance to diseases. There's probably some plant growth regulating type of compounds are being that the bacteria is manufacturing, but we have to figure that out. All right, so that's your toolbox. That's what we have out there. Those are the things that you can do to mitigate. Remember, mitigation is just trying to deal on a short-term basis with the problem so that we can continue growing what we're currently growing. What we really need from a long-term standpoint is adaptive changes. So one would be just stop growing things that are harder to grow in the heat here and grow things that like the heat. So one example, we're getting increased acreage of sweet potatoes again in our region, and it certainly grows well in the heat. Changing our planting season. So we've had a lot of problems with broccoli this past year because we had a really hot September and it just did not go well with broccoli. And so we can plant it later. All right, avoid spring plantings. The trouble there is you eventually run out of day length. So you can keep planting things later and later. Eventually you can't plant it anymore late. Or you have to move to Canada where you have longer day lengths. So, by the way, for what I learned from the Tuesday's talks is start investing in land in Canada. Changing your cultivars. These are crown temperatures that we measured on plants, 2 different varieties. This one has a real narrow adaptation to temperature. This one has a wider adaptation. So changing your varieties so they're better adapted. And then breeding programs for heat tolerance, and this is what my colleague Emily is going to talk about. That's where we need to head, where it's possible to breed heat tolerance in. So with that, I'm going to have to leave you because I have to go teach a lab and I got to get on the road. But while Emily's and we're changing over, if you have a question or two. Yes.
You also see changes in the weed populations due to the changes in the
all kind. Yeah, the biology. We're going to see a lot warm weeds that really, well, you know, the one that we're having all kinds of problems now with. The amaranth family is a real problem, and there's chenopod's a real problem in that family. Plus, they're cold tolerant too, so we can grow in the heat, grow in the C4 plants, and yep. Yeah, there's all kinds of changes that are going to come. Eventually, we're going to have the climate of Virginia, and not too soon a future.